Hello, in this video we'll be working through Unit 5 homework problems 25 through 28, and these are still dealing with particle motion. Number 25, if the position of a particle is defined by the function x of t equals t cubed minus 9t squared plus 24t, where t is greater than 0, is the speed of the particle increasing or decreasing when t equals 2.5? In order to answer this question, we want to consider the velocity and the acceleration at this time, t equals 2.5. So we have our position function that's given, x of t. Our velocity equation, v of t, is just x prime. So we want the derivative of x, and that is 3t squared minus 18t plus 24. Now we can leave the equation like this, or we can factor it. In order to figure out if my speed is increasing or decreasing, I want to know if this is positive or negative at time t equals 2.5, and I'm trying to do this without a calculator. So squaring 2.5, multiplying it by 3, subtracting 18 times 2.5 might be a little bit annoying. We can make this easier if we can factor, so I'll start by factoring out a 3, and that leaves behind t squared minus 6t plus 8. Now can we factor t squared minus 6t plus 8? So that would be t minus 2, looks like, and t minus 4. Let me multiply that back in my head real quick. So that's t squared minus 4t minus 2t plus 8. That looks good. So now v of 2.5, I really just need to determine if that's positive or negative. I don't need to figure out exactly what it's equal to. So 2.5 minus 2 is positive. 2.5 minus 4 is negative, so I'm multiplying 3 times a positive times a negative. That's going to be negatives. V of 2.5 is less than 0. Now let's move on to acceleration. So the acceleration equation is the derivative of the velocity equation, v prime of t, or we can say x double prime of t. I'm just going to call it a of t to remind myself that it's acceleration. So the derivative of velocity is 6t minus 18. And then that would factor as 6 times t minus 3. At t equals 2.5, 2.5 minus 3 is negative. 6 times a negative is going to be negative. So I have, at this time, 2.5, my velocity negative and my acceleration negative. And when the velocity and acceleration have the same sign, the speed of the particle is increasing. So we can say the particle is speeding up at time t equals 2.5. Do we have units there? We do not. So the particle is speeding up at t equals 2.5 since a of 2.5 and v of 2.5 are both positive. Number 26, the function whose graph is pictured below represents the velocity of a particle. Okay, so this is our velocity graph, moving along the x-axis from time t equals 0 to t equals 9 seconds. On what intervals is the particle moving to the right? The particle is moving to the right where the velocity is positive, and that means the graph of velocity is above the x-axis. So the graph is above the x-axis on the interval from 0 to 1. And then also on the interval, well, it's not exactly 5. I'm looking at this point right here. And we don't have the equation to figure out, well, we can get the equation. I can estimate it's about 5.2. If we wanted to figure out exactly what that is, we would have to get the equation for this linear portion of the graph. I guess I'll go ahead and do that. I'm not sure that's what I intended for you to do, but let's go ahead and do that. So we have the point 3 comma negative 3, 3 comma negative 3. That's this point right here. And then this point right here is 6 comma 1. So we can find the equation of the secant line passing through those 2 points, right? Our slope is going to be 1 minus negative 3 over 6 minus 3. So we have a slope of 4/3. So y minus something equals 4/3 times x minus something. So our points are 6 and 1, like so. And what I'm trying to figure out is where is the x-intercept of this line. So to find an x-intercept, you let y equal 0. So now I have 0 minus 1 equals 4/3 times x minus 6, and we're solving for x. So I can add 1 over to the other side, and I'm going to also distribute this 4/3. So I have 4/3 x minus 24/3, which is 8, plus 1 that I'm bringing over. And actually, I'm just going to move that plus 1 back over to the left, and I'm going to add 8 to the left as well. So then I have 7 equals 4/3 x, and I can multiply both sides by 3/4, which will get rid of this. So 21/4. X equals 21/4. So that is 5.25. So my guess of 5.2 was pretty close. Okay, that's 5.25. So again, we are looking to see where the particle is moving right. So that's where velocity is positive. It's positive from 0 to 1, and then from 5.25 to 7. Might be a little hard to see here, but between 7 and 9, the graph is just sitting on the x-axis like so. And justifying our answer, I have to indicate direction. Okay, so moving right, so we'll just do it this way. The particle is moving right on the interval from 0 to 1, union 5.25 to 7, since v is greater than 0. And then the particle is moving left on the interval. So now I'm looking to see where's my velocity negative, and that's everywhere between 1 and 5.25. So 1 comma 5.25, since v is less than 0. Part B, on what intervals is the particle slowing down? So we have a couple of ways we can answer this question. I think one of the easiest ways would be to take the absolute value of our velocity graph. Let me change color. So if I take the absolute value, all of these negative velocities are going to reflect across the x-axis and become positive velocities. So instead of having this point at 2, negative 3, on the speed graph it becomes 2, 3, like this. It flips up like this. So the positive part of this graph stays the same. And then, let's see, it's going across, and then it's going like so. The positive part remains the same here, and then at 0, that part remains the same. So that is my speed graph. If I want to know where is the particle slowing down, that's wherever the speed graph is decreasing. So from 0 to 1, we can see the speed is decreasing. And then also right here, speed is decreasing. And then this little portion right here, speed is decreasing. So we can say slowing down on the intervals, see 0 to 1, 3 to 5.25, and 67. Now, for justification, I looked at the speed graph for that, but let's think about how else we can justify that. Let me erase my speed graph. And then we can say, I might have to, so the reason is going to change, so I think I'm going to have to break up these intervals. Okay. So we'll say slowing down on the interval from 0 to 1, since velocity is positive and decreasing. And then on the interval from 3 to 5.25, since velocity is negative and increasing. Negative and increasing. And then I think we had one more, 6 to 7. Okay, and then 6 to 7 since velocity is positive and decreasing. And then speeding up, okay, so speeding up, and I erased my speed graph, but we could also use that to answer this question. Speeding up on the interval. Okay, so for speeding up, I want positive and increasing, so that's here, this portion here. Or also it could be negative and decreasing. So negative and decreasing would be right here. So from 1 to 2, and then from 5.25 to 6. And the reason is different, so I'm going to split those up. So on the interval from 1 to 2, since velocity, I'm just going to say v of t to save room, v of t is negative and decreasing. Negative and decreasing. And then also we're looking for positive and increasing. So that was our 5.25 to 6. Since v of t is greater than 0 and increasing. Part C, at what values of t is the particle momentarily stopped and changing direction? So momentarily stopped would mean that our velocity is equal to 0. Changing direction would mean that our velocity is changing sign. So let's start with where our velocity is 0. That happens at t equals 1, right here, and at 5.25 right here. And then our velocity is also 0 all the way from 7 to 9. But where is the velocity changing direction? We need a sign change in our, or where is the particle changing direction? We need a sign change in our velocity. So that happens here. The velocity is changing from positive to negative. It happens here. Velocity is changing from negative to positive, but it does not happen at 7 or any value between 7 and 9, because there the velocity is constantly 0. It's not changing sign. So the particle is momentarily stopped and changing direction. I'm just going to say it's changing direction. At t equals 1 and t equals 5.25, since velocity changes sign. And part D, on what interval of time is the acceleration 0? The acceleration is 0 when the derivative of velocity is 0. Where's the derivative of our velocity graph? 0. The derivative is going to be 0 between 2 and 3, but not at the endpoints there. And then between 7 and 9, but not at those endpoints there. So 2, 3, union 7, 9, since v prime of t equals 0. Number 27, a particle moves along the x-axis so that its position for time t greater than or equal to 0 is given by p of t equals t cubed minus 4t squared minus 3t plus 1, where p is measured in feet, t is measured in seconds. Find the average velocity on the interval t equals 1 to t equals 2, and give our answer using correct units. This is a calculator active question. The setup for average velocity is going to be the change in position over change in time. So p of 2 minus p of 1 over 2 minus 1. So let's enter our position equation. We've got t cubed minus 4t squared. Oh, let's try that again. T cubed minus 4t squared minus 3t plus 1. Now I want to find p of 2, so I'm using my F4 menu, y1 of 2 minus, I always forget to set this up as a fraction, but that's okay. F4, y1 of 1, and then we're going to divide that by 2 minus 1, which is still going to give us negative 8. Now the position is measured in feet, so change in position is feet divided by the change in time, and our time is measured in seconds. So our units are feet per second. Part B, on what intervals of time is the particle moving to the left? The particle is moving to the left where the velocity is positive. So I want to take a look at my velocity equation, and I'm just going to turn off this equation so it doesn't show up on my graph. And my velocity equation would be the derivative of this, so 3t squared. Let's try that again. 3t squared minus 8t minus 3. The particle is moving to the left where the velocity is negative. So I need to find these x-intercepts because I can see that my solution is in between these two x-intercepts. So let me make my window a little better here. Go from negative 2 maybe to 5. Okay. Now we want to find these x-intercepts, so I'm going to use second calc and then 0. So I have one at negative 0.3 repeating, so negative 1/3. And 3. Oh, that was easy. Negative 1/3 and 3. Okay, since v of t is less than 0. Part C, where we want to find p prime of 3 and p double prime of 3. Based on these values, describe the motion of the particle at t equals 3 seconds. So let's go back to our calculator. And I'm going to put p prime in y1. And then p double prime would be the derivative of p prime. So the derivative of 3x squared is 6x. And then derivative of negative 8x is negative 8. So now I have p double prime in y2. To find p prime of 3, since I have the p prime equation in y1, now I can do y1 of 3. And I get 0. P double prime of 3, I have the second derivative in my y2, so now I can go into F4 and choose y2 and find y2 of 3. And that is 10. The other thing I could have done here is I could have used math 8 to get the derivative of the original function, which I'll have to retype now because I cleared it out of my equation list. But we had x to the power 3 minus 4t squared minus 3t plus 1. And we were trying to evaluate that when x is 3. So here, the calculator is going into scientific notation. 1 times 10 to the negative 6 is technically not 0, but the answer should be 0. So sometimes we do get this round-off error in the calculator just due to the algorithm that it's using to compute this value. So we found that p prime of 3 was equal to 0 and p double prime of 3 was equal to 10. So what does that tell us about the motion of the particle? Well, the p prime is our velocity, and that's 0. P double prime is our acceleration, and that is positive. So the particle is neither moving left nor right. It's temporarily at rest at time t equals 3. But it has positive acceleration. So we can't say it's speeding up or slowing down. It's just momentarily at rest. Now we could also conclude that the particle is getting ready to change direction. Because remember the relationship between p prime, p double prime. If p is our position graph and p prime is positive, that means our position graph is concave up. And we have the first derivative of p, 0. So 0 and concave up means that our position graph has a relative minimum. It has a relative minimum if the first derivative at this point is 0 and the second derivative is positive. So we get this concave up shape. So that means our position graph at this point is changing from decreasing to increasing, which means our velocity is changing from negative to positive at this point. So we are getting a change in direction. So the particle is momentarily at rest and changing direction. And the velocity is changing from negative to positive, so changing direction from left to right. Part D, what is the maximum velocity on the interval from t equals 0 to t equals 3 seconds? Show the analysis that leads to your conclusion. Maximum velocity. So our velocity equation, let me write that again, velocity equation, 3t squared minus 8t minus 3. We just want to know where this has a maximum on the interval from 0 to 3. So we can graph this and see where it has a max. Or we could say, well, that would be wherever the derivative of this changes from positive to negative. So that's two different ways you can approach this problem. We can graph the velocity, look for a maximum, and find that y-coordinate. Or if we wanted to, we could find the acceleration equation, which would be a simpler equation to work with because it would be linear. It's just 6t minus 8. In fact, let me write that down. So acceleration would be 6t minus 8. And there we would just want to know where that's changing from positive to negative. Let's go back and look at our graph again. And let's see what we're seeing the graph of. I haven't updated this. Two graphs here. So the blue graph is the velocity graph. The red graph is the acceleration graph. And we are looking for the same x value on each of these graphs. We're just looking for different key features. So on the blue graph, the velocity graph, I'm looking for that. Well, actually, it's got a minimum, but I'm looking for maximum velocity on the interval from 0 to 3, was it? 0 to 3. So let's change my window so I only see what's happening from 0 to 3. That would be helpful. And let me go a little further to the right and further up. No, not further to the right. We want to stop at 3. I might have to go up a little further, but I'm not sure about that even. Let's just try 15. Okay, so I can see on the graph that the velocity equation, the blue one, reaches its maximum on this interval at 3. And it looks like the value at 3 is 0. And I can see in the table down here, in fact, when x is 3, yes, velocity is 0 and acceleration is 10. Well, we knew that already. We found that already earlier. So 0 is the maximum velocity on the interval from 0 to 3. Okay, then part E. Find the total distance the particle moves on the interval from 1 to 5. Total distance. So we need to consider where on the interval from 1 to 5 does the particle change direction, if it does change direction. So let's fix my window here again. Now we're just interested in what is happening from 1 to 5. And I want to stick with 1 to 5, so I don't need to change x min, x max, but it looks like my y max needs to be a little higher. There we go. Find the total distance the particle moves on the interval from 1 to 5. Does it change direction? Well, the blue graph underneath, that is my velocity graph. And the particle changes direction when the velocity changes sign. It looks like that happens at 2. No, at 3, because this window starts at 1. Right. Velocity passes through 3, 0. So at 3, we have a change in direction. At 3, we have a change in direction. That means we have to split up our interval. We go from 1 to 3, and we find that net distance. And then from 3 to 5, and find that net distance. So let's write our plan over here. We're going to split this up and go from 1 to 3, and then 3 to 5. And by plus here, I just mean, well, I don't know if that's proper notation, but I'm going to find the net distance on the interval from 1 to 3 and add it to the net distance traveled on the interval from 3 to 5. So the net distance from 1 to 3 is going to be P of 3 minus P of 1. Plus, and then we have to take the absolute value of that. Plus the net distance from 3 to 5. So that's P of 5 minus P of 3. And then we take the absolute value there, add these together, and that's going to give us our calculation for total distance. So I do not need to use this. Actually, I need to go back to my position equation. Let me enter my position equation. So that was the original t cubed minus 4t squared minus 3t plus 1. And I want P of 3 minus P of 1. Now that's negative 12. We need to make that positive 12. So our first net distance is 12. And then my second net distance is going to be P of 5 minus P of 3. I'm going to hit second enter so I don't have to type all that stuff over again. And then I'll just replace the 3 with a 5 and the 1 with a 3. And that one is 28. So my total distance is going to be 12 plus 28, which is 40. So 12 plus 28 is 40 feet for our total distance traveled. And our last question, a particle moves along a line so that at time t between 0 and pi, its position is given by s of t. What is the velocity of the particle when its acceleration is 0? So I'm going to rewrite s of t. That's negative 4 cosine t minus t squared over 2 plus 10. I want the velocity, which would be s prime of t, when its acceleration is 0. So there's really a couple parts to this problem. We have to find the velocity equation. We have to find the acceleration equation and set it equal to 0 to figure out at what time t does the acceleration equal 0. So although this is a calculator active problem, we do need to get our velocity equation and our acceleration equation without the calculator. And then we'll use the calculator to solve for t. We'll set acceleration equal to 0 and solve for t, and then we'll use that value of t to find our velocity at that time. So s prime of t is velocity. And that is going to be, so the derivative of cosine is negative sine, so we get 4 sine t, because of that double negative. And then t squared over 2, that derivative becomes 2t over 2, or just minus t. And the derivative of the 10 just becomes 0. Acceleration, that's my second derivative of position. Derivative of sine is cosine, so I have 4 cosine t minus 1. When is our acceleration 0? Acceleration is 0 when 4 cosine t minus 1 equals 0. We'll add 1, divide by 4. we get cosine t equals 1 over 4. Now, when we're thinking about solutions here, we have to consider our interval. We're working on the interval from 0 to pi. This is calculator active, so we can solve this by graphing cosine t and then seeing where it's equal to 1/4 on the interval from 0 to pi. Or we could take the arc cosine of both sides and then figure out which solutions, how we have to adjust that solution to give us answers on the interval from 0 to pi. But I think the easiest way will just be to graph cosine t and then see where it's equal to 1/4. All right, so we've got cosine of x and then 1/4, which is 0.25. Oh, that's not what I meant to change. Although we are working on the interval from 0 to pi, so we can make that x min, x max 0 in pi. And then x min, y min, I was going to go for -1 to 1. So I'm only looking right now on the interval from 0 to pi, and I only have one point of intersection there. So that's the only one that we need to find. Second calc, intersect, enter, 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 and I've got 1.318. 1.318. That's the time when acceleration is 0. And we want to find the velocity at that time. So now we're going to find v of 1.318. v of 1.318. Write that over here. v of 1.318 equals, and bring the calculator back up. I need to enter my velocity equation now. My velocity equation is 4 times the sine of t minus t. And I want to find the value of that function at 1.318. Now, since I just found that point of intersection, it should be stored in x. So I've hit alpha x, enter. There's that value, and so I can use that without having to round it. My velocity equation is in y1, so now I want y1 of that answer. And we get 2.555 if we round to 3 decimal places, 2.555. So that is the velocity of the particle when its acceleration is 0.